Hello everyone, welcome back to the problem solving sessions for the course on Introduction to Probability and Statistics. I am Shreya, one of the TAs for this course, and today I'll be discussing, or rather I'll be solving the exercise problems which were given during week 4 and week 5 assignments. So I'll be solving those assignment questions, and I'll wait for one more minute and then we'll start. Alright, so we'll move on to the first question for today. So this one says that we assume x follows a normal mu sigma square random variable. It is normally distributed with mean mu and variance sigma square. Then what is the distribution of 4x minus 9? Now this 4x minus 9 is in the form of plus some ax plus, or rather you can say some cx plus d. Okay, so this is a linear combination of random variable x. So since x follows a normal distribution, any linear combination of the random variable x, so if x follows normal, cx plus d, where c and d can belong to any number in the real line, will also follow a normal distribution. So there is no doubt that this x bar or cap or curl, whatever it is, 4x minus 9 will also follow a normal distribution. Now what will be, this is fixed that this will also follow a normal distribution. As you can see in the options, we also have all 4 options are for normal distribution. Now this one, expectation of this x curl is expectation of 4x minus 9. Now for expectation, we can take expectation, we can break it down like this: expectation of 4x minus 9, this is a constant variable, so there won't be any expectation term over here. So expectation of 4x, then we can write as 4 into expectation of x minus 9. So this would be 4 mu minus 9. So expectation is this thing, and variance one second, my pen doesn't seem to work, just give me a couple of minutes. So for variance, similarly we are going to calculate. Now variance calculation we have discussed. So for calculating variance, what we'll do, variance of x or variance of some cx plus d is always equal to variance of cx. It's independent of shift in independent of translation, but it's not independent of scale. So this would be c square variance of x. So as here we had variance of 4x minus 9. This would be variance of 4x. This would be 16 variance of x, which is 16 sigma square. Therefore, the final answer is x curl or whatever it is, it follows normal 4 mu minus 9 16 sigma square. This is the final answer. That is option D. Alright, so now we'll move on to the next one. So here they are saying two athletic teams play a series of games. The first team to win 4 games is declared the overall winner. Suppose one of the team is stronger than the other and wins each game with probability 0.6 independently of the outcome of other games. Find the probability that the stronger team wins the series in exactly 4 games. Okay. So if I say xi is the random variable which denotes or rather I'll write x is the random variable which denotes number of games won by the stronger team in a series of 4 games. So x can take values, x could be 0, 1, 2, 3, 4. The stronger team could lose all the games, could win all the games, and that in that case x would be exactly equal to 4, and there could be 1, 2 or 3 number of wins. So then this is and also probability that stronger team wins is equal to 0.6. So x here follows a binomial distribution where n equal to 4 and success probability, that is probability of winning, is 0.6. Note if this this could be formulated as the probability of loss of the stronger team as well. In that case the p's would change. Okay, accordingly it would become 0.4. In that case the success probability would be probability of losing. So please bear this in mind. You have to frame the questions and the probabilities accordingly in order to arrive at the correct answers. Okay, so this one is binomial NP. So now we have what is the probability that the stronger team wins the series in exactly 4 games. Okay, so then exactly 4 games he has one is probability x equal to 4, which is equal to, it's a binomial thing, so it would be binomial probability is how much? Probability x equal to n cx p to the power x 1 minus p to the power n minus x. So we would substitute over here 4. So this would be 4c4, n is also 4, 0.6 to the power 4 into 0.4 to the power 6. Sorry, 0.4 to the power not 6, 0. 4 minus 4 will be 0. So this comes to 0.6 to the power 4 this will be 0.36 square, then it would be 1296 0 point. So this would be 0.1296. Okay, so anywhere if you put your answer between this range, you would have gotten a +1. All right, so next we'll move on to the next one. This says that we assume that the life of a laptop is exponentially distributed with a mean of 3 years. Suppose you buy a laptop today, what is the probability that it will work for more than 5 years? Now, here the random variable is, so let x be the random variable denoting lifetime of a randomly chosen laptop. Okay, so x follows exponential with mean equal to 3. So then PDF of x would be fx equal to mean is 3. So we have to write 1 by 3 e to the power minus x by 3 when x is greater than 0. Okay, so why is this? X greater than equal to 0. So you remember, if we formulate fx equal to lambda e to the power minus lambda x, then expectation of x would be 1 by lambda. Okay, 1 by lambda equal to 3 means lambda equal to 1 by 3. If this is the formulation, this is the formula. If we write fx equal to 1 by lambda e to the power minus 1 by lambda x, then expectation of x in this format will be lambda itself. Okay, so here expectation is 3, so we have written it in this format, 1 by 3 e to the power minus x by 3. Alright, now what is the probability that it will work for more than 5 years? So if you remember, so CDF of an exponential, or I'll write in another color. CDF of an exponential distribution is given by fx equal to probability capital X less than equal to small x 1 minus e to the power minus lambda x. Okay, so if you remember this, then probability capital X greater than x is 1 minus fx, which is equal to e to the power minus lambda x. So accordingly here small x equal to, it should work for more than 5 years. So we have probability x greater than 5 equal to e to the power minus 5 by 3. This is the answer. So this is answer B. Okay. Alright, so then we'll move on to the next one. Alright, so here they are saying the width of a slot of a duralumin forging is in inches, normally distributed with mu equal to 0.9 and sigma equal to 0.003. The specification limits 0.9 plus minus 0.005. What percentage of forgings will be defective? So x is our random variable denoting width of a duralumin forging. Okay, now probability probability sorry for this disturbance. Yeah, so percentage of forgings defective is equal to probability x does not belong to this limit, 0.1 plus minus 0.005, which is equal to probability either x is less than 0.9 minus 0.005 or probability x greater than 0.005. Now since this one, let's say this is A and this is my B, event A, event B. Now A intersection B is phi. A same number cannot be less than 0.9 minus something. So let's say this one is 0.9, this is 0.9 minus 0.005 and this is 0.9 plus 0.005. So a number, if it is lying here, it can never be less than this thing. On the other hand, if the number is lying somewhere here, it can never be greater than this thing. So these two events are, this is what you call mutually exclusive. So that is why when we had some probability A union B, that it is either less than this or greater than this, then we could write this as probability A plus probability B minus probability of A intersection B. This thing, it is phi, so we could write it as probability A plus probability B. Okay, so when I am writing that x is either less than this or it is greater than this thing, because it falls outside the specification limits. Since these are mutually exclusive, we don't have the intersection term, because the probability of intersection, it's phi, it will go to 0. P of phi is 0. Alright, this is mutually exclusive, not independent but exclusive. Please keep this in mind. Alright, so once we have this, now we are going to find out how to solve for this. So here we have probability x less than 0.9 minus 0.005 plus probability x greater than 0.9 plus 0.005. Okay, now we have already been given that x follows a normal with mu equal to 0.9 and sigma equal to 0.003. Okay, so now we'll write it as like this. So P x minus mu by sigma is less than 0.9 minus 0.005 minus 0.9 by 0.003 plus probability x minus mu by sigma greater than 0.9 minus 0.005 minus 0.9 by 0.003. So now if x follows normal mu sigma square, if we do x minus mu by sigma, this will follow a standard normal. Okay, this is an established result. If we just subtract the mean of the distribution and divide it by the standard deviation, then we would have transformed a normal mu sigma squared to a standard normal variable. Now this one we can write it as a probability z. Okay, so z less than minus 0.005 by 3, that would be minus 5 by 3, minus 5 by 3 plus probability z greater than, so this is plus, sorry, so this will be, one second, so this will be greater than 0.005 by 3, that is 5 by 3. Okay, so this one we can write it as probability z less than minus 1.67 plus probability x greater than 1.67. So this is a, let's say this is a standard normal variable. Okay, so this is z0, this is 1.67 and this is minus 1.67. So standard normal variable is symmetric about 0. Alright, so now this one we can write as z less than minus 1.65 plus probability z greater than this thing is this area plus this area. So this we can write it as 2 into probability this area, because this area and this area are the same. So we would have, this is not x, this will be z. Okay, so z greater than 1.67. This we can write as 2 is 1 minus probability z less than equal to 1.67. Now from the table, if this is what a standard normal table looks like, so how we have to read it is, here we have probability z less than equal to 1.67. So this will be the first decimal place, first decimal down, and here we have to go up to second decimal. So we have 1.67. So here we are going to find out 1.6 and here we are going to find out 1.6 here, and here we are going to find out 0.07, that is this one. So the required value is this one, 0.9525. So what we have here is, so this one would be 2 into 1 minus 0.9525. It was 9525? Yes, it was 9525. So then this would come to be 0 into 0.75. Sorry, this would be 1 minus 0.9525, no? So 2 into 75, 0.0475. So this would be 5 to 1. 0.0975. Yes, this would be 0.95. So this will be 9.5%. This is our answer. So the percentage defective is 9.5%. Alright. So if there is no problem with this one, we will move on to the next one. Okay. So here they are saying if mean and variance of a binomial distribution are 5 and 4 respectively, then what is the value of n? So if x follows a binomial np, expectation of x is equal to np and variance of x equal to np into 1 minus p. So by the problem, but according to the problem, we have np equal to 5 and np 1 minus p equal to 4. So here we can write this as np minus np square equal to 4. So np is 5 minus np into p equal to 4. So we have 5 minus 5p equal to 4, which means p equal to 1 by 5. Alright. So if p equal to 1 by 5, then n equal to 5 into 5, that is 25. This is the answer. Okay. So let us move on to the next one. The question is, which of the following are the properties of normal distribution? Choose the correct answer from the options given below. So it is saying that may be symmetrical or skewed, bell-shaped and symmetrical, asymptotic to the x-axis, and mu and sigma are two parameters. So except the first one, all three are correct. Any normal deviation distribution looks like this. So this is bell-shaped and it is always symmetric about mu. Okay. Note that this any normal distribution is symmetrical about its mean, its own mean. So if I have, for example, a normal distribution, I say that mu is 4 and sigma is 5, then is it symmetrical about, so if I ask is it symmetrical about 0, then the answer is no. It is symmetrical around mu equal to 4. Okay. So if nothing is mentioned, it is implicit that it is symmetrical around its mean. But if there are options where they say something like this, then you should know which one to choose. Okay, so it is always bell-shaped and symmetrical, that is asymptotic to the x-axis. So as we increase x along this side and x along this side, so towards minus infinity and towards plus infinity, the fx value goes close to 0. Okay, it's heading towards 0. So then this is, by this we mean this is asymptotic to the x-axis. Y is tending to, so fx will go towards more and more towards 0. So we know that there are limits, like this is mu minus 3 sigma, this is mu plus 3 sigma. So only a very small percentage of observations will lie within these ranges, and if we just keep on extending, then the number of random variables which would fall in those extreme edges would be very, 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 very low, tending to 0. Alright, because the probability is very low for anything to be very far from the mean of the distribution. And of course there are two parameters, mean and sigma, in order to characterize or get the functional form of the PDF fully specified. Alright. Okay, so then we have this question: if the mean of a Poisson distribution is 9, then its variance is equal to what? So if x follows a Poisson lambda, expectation of x equal to lambda and variance of x is also equal to lambda. Therefore, variance of x will also be equal to 9. Okay, this is option B. Alright, so next let us move on to some more questions. Alright, so these questions are from week 5 lectures, week 5 assignments. Alright, so here we have been given a joint probability density of the random variable x and y given by this is the functional form of the PDF. The probability that x is less than or equal to 0 and y is less than or equal to 1. So before moving into this thing, we have to see what all values x and y can take and what should be the sign of mod x and mod y in those intervals or ranges, and then accordingly we have to prepare for these things. Alright, so the first thing that we are going to do here would be the first thing that we need to do is write down the joint PDF. So this is the joint probability density of the random variable x and y. So first of all we have to integrate. In order to find these probabilities, we have to integrate within those limits. Alright, sorry for this interruption or delay because I was connecting my laptop to the charger. Okay, yeah, so we are all set. This is the bivariate density function. Now, probability x less than equal to 0, y less than equal to 1 is nothing but x can take values from minus infinity to 0, y can take values from minus infinity to 1, and this would be fxy dx dy. Okay, this would be minus infinity to 1, minus infinity to 0 half e to the power minus x mod x mod y dx dy. So this one we can say that when x is ranging from minus infinity to 0, mod of minus x would be minus x. So here this is not dependent on x anymore, because it will be e to the power minus x into e to the power minus y. So we can take e to the power minus y out. So I am going to write it again. So what we have is minus infinity to 1, minus infinity to 0, half, or do we not have half? Yes, we do have half. So yes, half e to the power minus mod x minus mod y dx dy. So we will take this minus y out, minus infinity to 1, e to the power half also we will take out, minus mod y, minus infinity to 0, e to the power minus mod x dx, then dy. Okay, so this one we can write as minus infinity to 1 half e to the power minus mod y. So this is, x is always negative in this range, so negative mod x will be negative, negative of negative will be positive. So we would have minus infinity to 0 e to the power x dx. Okay, this would be minus infinity to 1 half e to the power minus mod y. This would be to the power x minus infinity to 0 dy. So this finally comes to minus infinity to y half e to the power minus mod y. E to the power x is 0 is 1 minus e to the power minus infinity, this is 0 dy. So we finally land up here. So this would be equal to minus infinity to 1 half e to the power minus mod y dy. Alright, now we have to see that we have to break this range minus infinity to 1. Here y can take negative values, mod y can take negative values, mod y can take positive values as well. So we are going to break it down into positives and negatives. So this will be integration minus infinity to 0 plus 0 to 1. So here when y is negative, e to the power minus mod y will be e to the power y dy, because minus y mod y would be minus of minus y, which would be plus y. This thing plus 0 to 1, here y is positive, so mod y is positive, so we would have half e to the power minus y dy. So this would be half e to the power y minus infinity and 0 plus e to the power half e to the power minus y at 0 and 1. So this would be half minus e to the power minus infinity is 0, 0 plus minus half into e to the power minus 1 minus of minus e to the power 0 would be 1. Okay. So here we would have half plus half equal to 1, 1 minus half e inverse. So it would be 2 into, sorry, it would be half into, half if we take common, 2 minus e inverse. This is the answer, half 2 minus e inverse. Okay, option D. Alright, so now we'll move on to the next one. Here we say that the joint PDF of a bivariate random variable is given by this, where k is some constant, then what is the value of k? So we know that if we integrate of f of xy, then this comes to be 1. So we are going to use the same thing and see what it comes to. So here we have x and y ranges are independent, nothing is dependent on the other one. So 0 to 1, 0 to 1, kxy dx dy equal to 1. Okay, so it doesn't matter 0 to 1 k x, let's say 0 to 1 y dy dx equal to 1. So this is 0 to 1 kx y square by 2, 0 to 1 dx equal to 1. This one we can write as 0 to 1 k x, because this is half minus 0, so x by 2 dx equal to 1. This would be k x square by 4, 0 to 1 equal to 1. It will be k by 4 equal to 1, which implies k should be equal to 4. This is the answer. All right. So now we'll move on to the next one. Okay. So let the joint probability density function for xy be fxy equal to x plus y by 3, where x can range from 0 to 2 and y can range from 0 to 1. Now we have to find probability that x is greater than y. Okay. So probability x greater than y if this holds true, then what we would have is 0 is less than, so the overall range in that case would be 0 less than y less than x less than 1, and 0 less than 2, and 0 less than y less than 1. Okay. So or in other words, if I have to find out this probability, then I should integrate in ranges where y is less than x, because x has to be, just a second, give me a second. Yeah, so x has to be less than 2 and y has to be less than 1. Okay, so this one would be, we would first integrate, let's say with respect to x. So x can range from y to 2, and then y can range from 0 to 1. Alright, so this one we are going to write as 0 to 1. This is with respect to x. So we would write here x square by 6 plus yx by 3 from y to 2 dy. So this would be 0 to 1, 2 square by 3, that is 4 by 6 plus 2y by 3 minus y square by 6 minus y square by 3 dy. So this term we can write as 0 to 1. I'll write it down here once again. So we have 4 by 6 plus 2y by 3, excuse me, then we have 2y by 3, then we have minus y square by 6, then we have minus y square by 3 dy. Okay, so then 0 to 1. So this would be 4 by 6y plus 2y square by 6 minus y cube by 18 minus y cube by 3 into 3 is 9. 0 to 1. So this will be 4 by 6 plus 2 by 6 minus 1 by 18 minus 1 by 9. So this is 1 minus 1 by 18 minus 1 by 9 is 1 by 8. So here this is 18, 1 by 18 minus 1 by 9, so this would be 18 minus 1 minus 2. So this would be 15 by 18, that is 5 by 6, and the answer is also 5 by 6. Alright, now we'll move on to the next problem. So here they have given the joint PDF of a bivariate random variable, which is given by this thing. Are x and y independent? State true or false. So for independence, excuse me. So for independence, we have to show that f of xy is a product of the marginals. Okay. Now fx is integration of fxy over dy. So this would be 6x square y dy, and y is ranging from 0 to 1. So this will be how much? This would be 6x square y square by 2, 0 to 1. So which is 6x square by 2, which is 3x square. Similarly, fy would be integration of fxy dx. So x ranges from 0 to 1. 6x square y dy, sorry, this would be y dx equal to y 6x cube by cube 0 to 1. Okay, so this would be 2y. Alright, now 3x square into 2y is 6x square y, therefore it is true. Alright. So if this is clear, then I am going to move on to the next one. Alright. This question says that if the joint PDF of x and y is this, this thing. Alright, so fxy is this thing. We have to find out expectation of x. Now expectation of x is how much? It is expectation, it is x into fxy, sorry, x into fx dx, which is integration x into f of xy dy into dx. Alright, so here now we are going to use it. So x is ranging from 0, we have 0 less than equal to x less than equal to 1, and for y we have y range is dependent on x. Okay, so here we would put x, first we'll put the ranges of y. So y can range from 1 to x, fxy will be 2 dy, and here we would have x x can range from 0 to 1 dx. So this would be 0 to 1 x, 2y, x to 1 dx. It would be 0 to 1 x into 1 minus, sorry, this would be 2 minus 2x, okay, dx. So that would be, so one second, so that would be integration 0 to, please pardon, that would be integration 0 to 1 x 2x into 1 minus x dx. So it is 0 to 1 2x minus 2x square dx. So this would be x square minus 2x square by 3, 0 to 1. So this is 1 minus 2 by 3, that is 1 by 3, 0.33. So yeah, this is the type range, 0.33. Anything between this, if you write, you would have gotten a +1. Alright, moving on to the next one. So here we have x and y be IID 01. Select the correct statements. So expectation of the distance between x and y is 1 by 3. Standard deviation of the distance between x and y is 1 by 3 by root 2, I mean 1 by 3 root 2. Expectation of the distance between x and y is 2 by 3. Standard deviation of the distance between x and y is root 2. So how should we go ahead and solve this? The first thing is, what is this variable distance between x and y? So distance z is actually modulus of x minus y, okay, absolute magnitude of distance between x and y. This is our variable. So we have to find expectation of x minus y, okay. Now x follows uniform 0 1, y also follows uniform 0 1, and these two are independent. This has been given. Alright, now so we can write expectation of x minus y can be written as range of x, range of y, x minus y, f of xy dx or dy dx. Alright, now what is f of x and y? Equal to fx into fy, since x and y are independent. Alright, now fx equal to what? Is equal to 1 if 0 less than equal to x less than equal to 1, 0 otherwise, because it follows uniform 0 1. Okay, so fxy is also 1 when, so we have to write the joint PDF as equal to 1 when 0 less than equal to x less than equal to 1, 0 less than y less than equal to 1, and 0 otherwise. Alright, so we have this. Now the question is, so now the question is, that expectation of distance between this thing. Yeah, so we have x, y. So here we have x, y, x minus y, fxy, dy, dx. Okay, this one we can write it as x can run from 0 to 1, y can run from 0 to 1, x minus y into 1 dy dx. Okay, because x is also ranging from 1 to 0 to 1, y is also ranging from 0 to 1. In this interval, this thing is defined. By this thing I mean the integral. It's not PDF will not take a 0 value. Okay. So then now we have to look at a few more things. Okay. So here x also ranges from 0 to 1, y also ranges from 0 to 1. Now, if x is greater than y, then x has to lie between 1 and 0. In such case, x minus mod of x minus y would be x minus y. But the range of x at that point should be 1 to y. Okay. So, or if we take the other way round, let's say we here inside we have written inside we have written this y first. So let us consider in this way. Okay, if y is 0 less than y less than x less than 1, then y minus x is negative. So mod of y minus x would be x minus y. Alright. So here we are going to write it in this fashion. So when y is ranging from 0 to x, mod of x minus y sorry for this, I'll clear this once and for all. So let's say you consider in this manner. Okay, so we have mod of x minus y. Now suppose 0 less than y less than x less than 1. Suppose this is the case. Then x minus y modulus, this difference would be greater than 0. Sorry, x minus y will always be greater than equal to 0 and x minus y would be greater than 0. So we can write it as x minus y dy dx. Okay, where x can take values from 0 to 1. Also, in cases where 0 less than y less than, in cases where 0 x is less than y, so this thing, in such cases x minus y would be negative. Alright, so mod of x minus y would be minus of x minus y, that is y minus x. So in such scenarios, in such circumstances, what we would have is what we would have is 0 to 1 Now y would range from x to 1. So we would have x to 1 and mod of x minus y would be y minus x dy dx. I am hoping this formulation is clear now. So mod of x minus y, there can be two options, either x is greater than y. In that case, mod of x minus y would be positive, mod of x minus y would also be plus x minus y. Okay. So here we are putting x minus y. The other cases when x is less than y. In such cases, x minus y is negative. So modulus of a negative number is minus of that thing, that number. That is why when we take modulus, we land up at a absolute positive number. So if x minus y is less than 0, then mod of x minus y would be minus of x minus y, that is y minus x. So that's how we have kept it over here. So now we have no other thing to do than to solve. Okay, so I'll write this down once again. So here we have x minus y equal to 0 to 1, 0 to x, x minus y dy dx plus 0 to 1, x to 1, y minus x dy dx. So this one we can write it as 0 to 1 xy minus y square by 2 at 0 to x dx plus 0 to 1 y square minus y square by 2 minus yx at 1 to x dx. This one we can write as integration 0 to 1 x square minus x square by 2 dx plus 0 to 1, this would be half minus x minus of x square by 2 minus plus x square dx. So what we would have is, here x square we would have 0 to 1 x square by 2 dx plus, here we have half minus x square plus x square. So we would have half minus x, 0 to 1 half minus x, and here we would have minus x square by 2 plus x square. So we would have plus x square by 2. Okay. So this would be x cube by 6, 0 to 1 plus half x minus x square by 2 plus x cube by 6, 0 to 1. So this would be 1 by 6 plus half minus half plus 1 by 6 minus 0. So this would be half plus 1 by 6 plus 1 by 6, that is 2 by 6 is equal to 1 by 3. So this is proven. Expectation of distance between x and y is 1 by 3. Now we have to find out the standard deviation of the distance between x and y. So this we know, for standard deviation we have to find out the variance of x minus y. Okay. So this is expectation of mod of x minus y whole square minus expectation of mod x minus y, this one's whole square. This thing we know is 1 by 3. So now right now we have to find out this thing. So this is what expectation of x minus y whole square. Alright. So again this one we will write in a similar fashion. So here what do we have? Here everything will be the same. Here instead of, here since we have x minus y whole square, whatever be the limits, when x is less than y or y is less than x, these limits will not change, but if it remains the same, the internal thing will also remain the same. So what we have is, this would be, here what we had, here we had that when 0 to 1, when y is between 0 to x, then y is strictly less than x, alright. But even then, x minus y whole square would be x minus y whole square dy dx, plus when it's the other way round, when y is from x to 1, we would have same thing, x minus y whole square dy dx. Okay, so this one, if we do, what will get? We get 0.021 0 to x square minus plus y square minus 2xy or instead of breaking it down here, we can see this thing very easily. So y can range, so this is the same thing, 0 to 1 something dy dz, 0 to x something dy dx. It looks like that the entire thing has been split up into two groups. Instead of doing this, we can just write here 0 to 1 x minus y whole square dy dx. Okay, so we have clubbed these two together. So we have 0 to 1 x square plus y square minus 2xy dy dx. Okay, so we will solve for it. We will see what it comes. 0 to 1 x square minus 2xy plus y square dy then dx. So this would be 0 to 1 x square y minus 2xy square by 2 plus y cube by 3 into dx. Okay, so here we would come 0 to 1, this entire thing would be, we will substitute for y, so we would have x square minus x plus 1 by 3 dx. So this would be x cube by 3 minus x square by 2 plus 1 by 3x from 0 to 1. So here we would have 1 by 3 minus 1 by 2 plus 1 by 3. So this would be 2 by 3 minus 1 by 2. That is how much? That would be, so it would be, I'll write it here afresh. 1 second. So here this would be, this is equal to 1/3 minus half plus 1/3. This is 2 by 3 minus half. So this would be 6. 2 to 4, 4 minus 3, 1 by 6. Alright. So here we have the variance equal, So now once we have this, variance of x minus y is expectation of x minus y whole square minus expectation of x minus y entire thing whole square. So this thing is 1 by 6 minus 1 by 3 whole square. So this one would be 1 by 6 minus 1 by 9. 1 second. So here we would have 18, 3 minus 2. This is 1 by 18. So standard deviation is 1 by root over 18. This is 1 by root over 9 into 2. This is 1 by 3 root 2. And this was the answer over here. standard deviation is 1 by 3 root 2, first and second one. Alright, I hope this is clear. What we all we need to do is make sure we put the correct ranges. Alright, so as long as we put the correct ranges, we will be able to solve these problems seamlessly. Moving on to the next one. So here we have that a group of n people throw their hats into the center of a room. The hats are mixed and each person randomly selects one. Let x equal to number of people who select their own hat. Number of people can vary from 1 to n. Okay, so let xi equal to 0, otherwise equal to 1 if the person I chooses his own hat, and then x equal to x1 plus xn, calculate variance of x. Alright, so before we know that variance of x is equal to expectation of x square minus expectation of x whole square. Alright, so let us first find out what is the expectation of x. X equal to expectation of x1 plus x2 plus dot 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 plus xn. So this would be expectation of x1 plus expectation of x2 plus expectation of xn. Okay, now xi equal to 0, xi equal to 1, sorry, if ith person chooses his own hat, okay, and 0 otherwise. Now probability of xi equal to 1, that is the success probability, is how much? Is this 1 by n. So there are n options to choose from. Okay, you have n hats, 1, 2, you could choose any one. So choosing that probability would be 1 by n. Alright, probability of success is probability xi equal to 1 is 1 by n. Alright, so probability expectation of x1 would be, so this is 1 by n for all I, it is not dependent on I. So this one would be expectation of x would be 1 by n plus 1 by n plus 1 by n. Okay, so this would be 1 by n n times. Alright, so this entire thing is okay. So this n would be a capital N, sorry, 1 second. This will be capital N in subscripts. Alright, now here then expectation of x would be 1 by n multiplied capital N times. Just bear with me for some time. pen has stopped working for some reason. We'll see. All right. Hopefully it will work now. One second. Extremely sorry. Okay, this would be cap 1 by n times, this would be n, so this would equal to, so this would equal to n into 1 by n, that is 1. So now we have the expectation, this thing. All right, now calculate the variance of x. All right, so now variance of x is how much? Variance of x equal to variance of x1 plus x2 plus xn. Okay, so this one would be variance of x1 plus variance of x2 plus variance of xn plus 2 covariance of xi xj, where xi and xj can range from I equal to 1 to n, j equal to 1 to n, I not equal to j. All right. So one thing we have to keep in mind is that xi is that ith person chooses his own hat. Here the chance of a person correctly choosing his own hat depends on whether, I mean, the xis are related to each other. Okay, so if someone chooses one hat correctly, then the probability of success in the for the second person to choose their hat, that changes. It's not independent in each of these trials. So let's say x1 is the random variable that first person chooses correctly. So first person will choose correctly with a probability out of n it will choose only one, it is 1 by n. Next, when the second person goes to choose his own hat, then he is not getting all n options. He is getting n minus 1 option. So for him or for that person, the success probability is changing from n to n minus 1. Okay, 1 by n minus 1, I'm sorry. So these, if I consider I to be ith trial, to go by the nomenclature, then xi's are not independent. Okay, so there would be some covariance terms involved, and we have to take those covariance factors into account. Now for each of the variance xi here, okay, so for each of these xi's, variance xi, it is expectation of xi square minus expectation of xi whole square. The expectation of xi square is how much? For each, it is expectation of xi square is 1 square into 1 by n okay, minus expectation of xi is 1, so it is 1 by n minus 1. Alright, or sorry, what am I saying? So expectation of variance of xi, variance of xi would be expectation of xi square minus expectation of xi whole square. Alright, so this would be expectation of xi square. Xi is 1 with probability 1 by n, 0 with probability 1 minus 1 by n. Okay, expectation of xi square will be 1 into 1 by n plus 0 into 1 minus 1 by n minus 1. So this would be expectation of xi is expectation of xi is 1 into 1 by n plus 0 into 1 minus 1 by n. So this is 1 by n. Alright, so here there was a problem. So here we have 1 by n plus 0 into 1 minus 1 by n, 1 square 0 square by 1 minus 1 minus n whole square. So what we would have is 1 minus n by 1 minus n square. So you would have n square n minus 1. This is the variance of each of the ith terms. Now what we have to do, we have to find out the covariance of the ith terms. Alright, so covariance between xi and xj is given by expectation of xi xj minus expectation of xi into expectation of xj. Alright, so here xi xj would be equal to 1 if xi equal to 1 and xj is also equal to 1 and 0 otherwise. Okay, so this means that this will be 1 if both ith person and jth person choose their own hats respectively. If either of them makes a mistake, this would come down to be 0. Okay, so probability now, probability xi xj equal to 1 is that the probability ith person chooses correctly out of n and jth person chooses correctly out of n minus 1. Okay, so this is equal to probability xi equal to 1, yi equal to 1, yj equal to 1, xj equal to 1. This is probability xi equal to 1, xj equal to 1 given xi equal to 1 into probability of xi equal to 1. Okay, so the first person, ith person, chooses the thing correctly. This is 1 by n. Given the ith person has already chosen, the jth person can choose in jth person can choose in 1 by n minus 1 ways. Alright, so this is the success probability of getting probability of xy xj equal to 1. So now expectation of xi xj is equal to 1 into 1 by n into 1 by n minus 1. This is 1 by plus 0 into 1 minus 1 by n into 1 by n minus 1. Okay, so which is equal to 1 by n into n minus 1. So once we have it, then covariance of xi xj would be 1 by n into n minus 1 minus expectation of 1 by xi is 1 by n, expectation of 1 by xj is also 1 by n. So here we would have something like this. So we would have n minus 1 into n. Here we would have n minus n minus 1. So this would be 1 by n square n minus 1. So this is my covariance term. Once I have my covariance terms, I am going to substitute this finally here. So now variance of x would be equal to summation of I equal to 1 to n. I can collapse this as variance of xi plus double summation I equal to 1 to n, j equal to 1 to n, I not equal to j, covariance of xi xj. So this would be variance of xi is, how much did we get? Variance of each xi is, this is n minus 1 by n square. This is n minus 1 by n square summation I equal to 1 to n plus double summation I equal to 1 to n, j equal to 1 to n, 2 into covariance of xi xj is 1 by n square into n minus 1. Okay, I not equal to j. So here we have n into n minus 1 by n square plus 2 by n square to n minus 1. Here we are taking summation of I not equal to j from 1 to n. So that would be, out of n we are choosing nc2. So this would come as n into n minus 1 by 2. Okay, so this would be then, this would be n into n minus 1 by n square. Here we are taking all possible 2 combinations. So we would all have, we already had n square n minus 1 into, we would have nc2. Okay, this thing we would have. So 1 and cancels, we would have n minus 1 minus n plus 2 by n square into n minus 1. nc2 is n into n minus 1 by 2. So the actual formula is RCK is R factorial by K factorial into R minus K factorial. So for 2 this one is holding if we have NC2. If we have NC3, then this formula would have been totally a mistake. Okay, so here that would have been n into n minus 1 into n minus 2. So factorial, you know, this one we can write, if we have something called 5 factorial, it means 5 into 4 into 3 into 2 into 1. Okay, so if we have NC2, this is n factorial, 2 factorial, n minus 2 factorial. So the upper part we can write as n into n minus 1 into n minus 2 factorial by 2 factorial into n minus 2 factorial. This cancels and we are left with this term. This is not a generic formula. This is where there are people who get confused and make mistakes, please be very wary of the situation, and you should, if it is not to, you should not directly substitute this formula and use it. Use your own jurisdiction, calculate, and then substitute the values. All right. Okay, so this one n cancels, n minus 1 cancels. Here also we have n minus 1 by n, 2 is going to cancel, and n is going to cancel, and so plus 1 by n. Okay, so this would be n minus 1 plus 1, that is equal to n by n, that is equal to 1. Okay, this is the answer. Alright, so I probably during one of the assignments there was some question on these things. I think it was week 6 lectures, if I am not too unsure. So there somebody had a question that if so the question was such that you had to choose, like there were m eminent personalities and you had to choose they had to choose their words correctly, something of this sort, if I remember correctly. Okay, so at that point initially the formulation looks like a binomial thingy, that you have to choose your own son or your own daughter out of the lot correctly. But the thing that you have to keep in mind is that there in binomial each of the xi's would have been independent. For each of the xi, getting your own child, the probability would be 1 by n. But when you have an exhaustive, like one person is assigned to another their own parents, then the options that you can choose from that reduces, which makes these xi's dependent on each other and not independent. And in that cases the binomial, you just can't use a binomial thing and get away with it. So you have to be extremely cautious, and then you have to follow these norms, and only then you'll be able to get it. So I can't seem to find this, but there was this problem here. I distinctly remember, I think week 7 or 8 somebody had problems with this. 1 second. Yes, this one, week 7 assignment 7. So expectation of x would have followed binomial NP, you would have thought, and variance x is NPQ, and then you could have obtained something which is not present in the formula. This expectation of x equal to 1, variance of x equal to 1, this is exactly the same problem that I solved now. With n pictures of babies, instead of babies I just said it's hats. Alright, so there you have to consider that once one person is correctly identifying their own child, the next person can choose from n minus 1. So the thing is, you are just choosing, then you are finding out the probability of choosing the correct one. So the number of options it's reducing. Alright, so you just bear this in mind. This is assignment week 7, assignment 7, question number 2, same as this one. Alright, here then expectation of x you got as 1, and variance of x is also variance of x is also 1. Alright, so if this is clear, we will move on to the next one. Here again we have a similar problem. Let x and y be two-dimensional random variables with such and such joint PDFs. Find the value of c. Same thing, double integration fxy bivariate, range of over x and y, dx dy, this would equal to 1. Now we just have to substitute. So y can, here it is easier to keep y inside and x outside, because the range of x is it's readily, you can see over here y is dependent on x. So instead of writing this thing, we will write 1 second. Instead of writing x inside and y outside, we would write y inside, okay, and x outside. So just reverse the order of integration. It doesn't matter in this case because it is there are some conditions. In case of a PDF it will not matter, okay. Alright, so here we can write it as y is ranging from minus x to plus x. So minus x to plus x, and x is ranging from 0 to 2. We have cx x minus y dy dx equal to 1. This would be 0 to 2 minus x to x cx square minus cxy dy dx equal to 1. This one we can write as, which is equal to 0 to 2 minus x to x, I'll write it again, cx square minus cxy, we would have here dy and dx. So this one would be 0 to 2 minus x to x, we'll write it later on. Let us write it in this manner, cx square y minus cxy square by 2 minus x to x dx. Okay, so then this one would be 0 to 2 c x square into x minus c x into x square by 2 minus of minus cx cube minus of minus plus minus of this one will be minus only because this is getting square. So minus x whole square will be x square by 2. Alright, so this one is 0 to 2 cx cube minus cx cube by 2 plus cx cube plus cx square by 2. So what we essentially have over here is equal to integration 0 to 2 2c x cube, okay, dx. Everywhere don't forget to mention this dx, okay. Here it would, you would also mention something. Here also it would be again it's not working. Alright. So dx, then this would be 2c x to the power 4 by 4 0 to 2. So this 2 will cancel out. Okay, everything is equal to 1, okay, right hand side everything is equal to 1. So we had c into 2 to the power 4 by 2 equal to 1. So 8c equal to 1 and c equal to 1 by 8. I will see if that is the answer. C 1 by 8. Okay, B is the answer. Alright. Okay. So now we'll move on to the last problem for today. So the previous question, find y less than 3 by 2 given x equal to 1. So we have the conditional distribution. Given x equal to 1, we have to find out that probability y is less than okay, so probability y less than 3 by 2 given x equal to 1, so this we can write as probability y less than 3 by 2 x equal to 1 by probability sorry, so this one we have been given that x is equal to 1. So that would be, so if x is equal, fx was how much? Fx was so fx was cx x minus y, cx x minus y when 0 less than x equal to 2, 0 less than x equal less than 2 and minus x less than equal to y less than equal to x. So probability x less than this thing would be probability y is less than minus 1 to 3 by 2 c into 1 minus y dy. Okay, so then this would be cy minus cy square by 2 minus 1 to 3. So this would be 3c minus 9c by 2. So then that would be equal to 3 c will be 8 minus 9 into 1 by 8 to 2. So 3 by 8 minus 9 by 60. No, there's some mistake that I'm doing here. This can't be it. Here the question is, for the previous question, find probability A equal to 1. So probability, so we have to find out the conditional distribution here. F of, sorry, so let us find out f of y given x. This is f of xy by fx. So fx is how much? Fx is, so here fx will be minus x to x cx x minus y dy. This will be how much? Minus x to x cx square minus cxy dy. This will be cx square y minus cxy square by 2 from minus x to x. So this would be cx cube minus c x to the power cube by 2 minus of minus cx cube minus of y square will be this thing, so it will be cx cube by 2. So what we would have here is cx cube, it will be 2cx cube, and this one would get cancelled. So 2cx cube is the marginal. So now once this is the marginal, f of y given x is given by f of xy by fx. So it will be cx something here, x minus y by cx's cube. Okay, so this would be, here cc would get cancelled, x minus y by, okay, it is 2cx cube, so it will be x minus y by 2x square. This is the f of y given x. Alright, so now probability y less than 3 by 2 given x equal to 1 is equal to, here we have to integrate x minus y by 2x square. So y can range from, what was the given x, y can range from minus x to plus x, right? So here we have to write that minus x to plus x, it will be 3 by 2. Okay, and given x is 1, we can substitute 1 over here. Sorry, we'll put minus x over here, then this is dy. Then we would have this would be x by 2x square y minus y square by 2 into 2x square, this thing, this one, given 3y from minus x to 3 by 2. Okay, so here we are going to substitute the value of y. So x into 3 by 2 by 2x square minus 9 by 4 by 4x square minus of minus x square by 2x square minus of x square by 4x square. Okay, so this one will be 3 by 4x minus 9 by 16x square plus half. Okay, and then plus this would be 1 by 4. Alright, so now at x equal to 1, we'll just substitute at x equal to 1, 3 by 4 minus 9 by 16 plus 1 by 4 plus half. So it will be 3 by 4, 1 plus 1 by 2, that's 3 by 2 minus 9 by 16. So this would be 3 by 2 minus 9 by 16, so it would be 16 into 8, 8 is 24 minus 9, so this would be 15 by 16. No. There is some problem with this one. So the process is the same. First we have to calculate the conditional distribution y given x. I think there's some problem in calculation. There's x minus y by 2x square. It is xy by 2x square. So it's x by 2x square. So y by 2x. Here it would be y by 2x minus this one would be y squared by 2 minus y squared by 4x square. 3 by 2 would be 3 by 4x minus x square. Given x equal to 1, we just substitute given x equal to 1, what do we get here? Here we get f of x given y, this is okay, so c by cx, this thing by c x cube, so c is cancelling, c by x square. While this is true, minus 9 by 4 by 4, so this is 16 x square plus half, this is minus of minus this thing, minus of, okay, this will be plus of minus x square by 4x square, yeah, this is correct, minus of, well, this will be plus 3 by 4, so plus 3 by 4 plus 3 by 4 is 3 by 2 minus 9 by 16, 8 3 is 24 minus 9 is 15 by 16. Somehow this is coming to be accepted answer is 1. I think I did some spelling mistake. The procedure is this thing. Okay, so I think there is some problem with this one. I'll redo it and post the solution online. Then I think you would be able to look into it. But the process is the same. If you have something like this, you have to find out the conditional distribution. Conditional distribution is f of y given x is fxy by fx. Find out the marginals, get the conditional distribution, and then once you have given x, just follow whatever x can y can take values from. If y can take values from, oh okay, I got it. So y can here, so this one is here, x is given as 1, okay. So when x is given as 1, y can be lie between minus x to plus x, okay. So if y has to be less than 3 by 2 given x equal to 1, then the bound should be minus 1 to plus 1, x minus y, this thing, okay. So here instead of 3 by 2 we would substitute by 1. So here, from here you would substitute from minus 1 to 1, alright. So here what we are going to do is, we will substitute x's with 1 and y is also, we'll do it, and then I'll see what comes, okay. But yeah, there was a mistake. Y can only range from minus x to plus x. Now y less than 3 by 2, it's exceeding 1, so y can also only range from minus 1 to plus 1. So if we solve for this, here what we'll write, so here we can write, instead of x we'll put y by 2 minus y square by 4. So this would be minus 1 to 1. So here we would have half minus 1/4 minus of minus half minus of 1/4. So this would be half minus half is 1, minus 1/4 plus 1/4 is 0. So this would be 1. This is the answer. Alright? Yeah. So the catch is here. First you have to find out this is called the conditional distribution. Okay? Get the conditional distribution, substitute given x whatever you have, and then find out so the conditional distribution here, y will range from minus x to plus x. This entire thing is the conditional distribution. Now here it is saying y less than 3 by 2, so of course y has to be less because x is 1. Y less than 3 by 2, y cannot take something more than 1, so here the range will be of integration would be from minus 1 to 1, okay. So here also we would put minus 1 to 1. I hope this is clear to you, and with that I have solved almost all problems of assignments 4 and assignment 5. So yeah, if you still have further doubts on assignment 4 and assignment 5, you can reach out to me or attend the next session. I hope these doubt clearance sessions and assignment solving sessions are helpful to you. Please reach out to the NPTEL team for further feedback, and thank you so much for joining and being there. Thanks a lot. Now I'm going to stop the session and we'll close it for now and we'll meet again in the next session. Thank you.